Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. And today's lecture topic is examples on power spectral density or power density spectrum. Okay, in this we are going to discuss the problems related to the power spectral density. Okay, we know the definition of power spectral density. What is the definition of power spectral density? Okay, it is denoted by Sxx of omega is equal to integral minus infinity to infinity Rxx of tau e power minus j omega tau d tau. This is one of the definition of power spectral density. Second definition is what? The limit t tends to infinity 1 by 2t expectation, okay, a into time average expectation of x square of t. Okay, these two are the definitions of power spectral density. Now what is asking in the question that they given in the question that random process x of t equal to a naught cos omega naught t plus theta. Now what is asking that find the power spectral density. Okay, to find the power spectral density I already said that whenever you are having some random signal or deterministic signal x of t, first you have to calculate autocorrelation function. After solving the autocorrelation function, then you have to solve the power spectral density. Okay, power spectral density. Now next, here you can check it. Okay, first apply the Fourier transform. Okay, apply the Fourier transform. Okay, apply the Fourier a naught cos omega naught t plus theta e power minus j omega t. You apply the cos term, cos, you know the formula of cos omega t e power j theta minus e power minus j theta by 2. You split this one, okay, e power j theta e power minus j theta by 2. You expand this one and you further simplify, then you will get minus t to t. E power j theta is constant, take outside the interval, then integral minus t to t e power j omega naught minus omega t, then dt, this one. Okay, this one is outside because both are not, okay, we are taking only in the terms of t. In terms of t we are taking. Then what you are going to get next? Next what you are having here, this one represents what? Sine part, sine omega naught, omega minus omega naught. You apply it, then this term you will get. Now next you are having also sine term, you will get omega plus omega naught, here omega minus omega naught. Substitute the limits, then whatever you are going to get the simplified form 2 bt sine omega naught tt by dt. Okay, this is a solution. Means first you have to calculate expectation, then we have to apply the power spectral density. Okay, now next here continuation of the problem, xt of omega, you simplify it further. Okay, xt e power jt sin omega omega minus omega naught t by omega minus omega naught t plus a naught t e power minus jt. Okay, again you simplify it further, then what is xt of omega whole square. Okay, this is a formula we already discussed, xt of omega whole square by 2t. Okay, this is one of the formula, xt of omega whole square, we have to get it. For that first you have to calculate xt of omega. This is, we know the relation, x of omega whole square is equal to x of omega into conjugate of that. Same thing, we are calculating the conjugate of that. The conjugate, whatever you are having positive sign, you will get the negative sign. Whatever you are having negative sign, you will get the positive sign. Okay, next you multiply both. Then what you are going to get? You multiply these two terms, then a naught square, that is a naught square you will get into t square sine square, this term you will get. Again here also same repeated, t square into sine square of that term you will get. Now you further simplify it. What are the j theta e power minus j theta, here e power minus j theta, e power plus j theta. Okay, e power 2 j theta, e power minus 2 j theta, sine term you will get it. Now next expectation of e power j2 theta minus e power minus 2 j theta, multiply and divide by 2, then you will get 2 cos 2 theta. 0 to 2 pi by 2 for the interval, then apply it, then you will get the resultant 0. Then what we required, expectation of xt of omega whole square by 2t, because what is the definition? This is the definition of power spectral density. Next, a naught t pi by 2, apply the limits, then limit t tends to infinity, sin square x by sin x square. You know the basic calculus formulas, sin square x by sin x square, this is phi, and this one t by pi sin square alpha t by alpha t whole square. Then what you are going to get, sin square x by sin x square, this is pi, pi will get cancelled, here t gets cancelled, you will get 1. Then apply the limit t tends to infinity for this, then what is the resultant you are going to get, which is equal to infinity, where if alpha equal to 0, it is 0, if alpha is not equal to 0. Consider these two statements, then the resultant, this is a property of impulse. This is a property of impulse. Okay, impulse property stands for at 0, that alpha, okay, delta of t, delta of t, what is the condition? It is infinity at t equal to 0, it is 0 at t not equal to 0. Okay, with the same condition it is applicable. Then substitute here, then omega minus omega naught, omega plus omega naught. That is, when you simplify it further, then you will get a square, a naught square by 2. Okay, this is average power. This is a formula of power spectral density. What is average power? We are having relation area under the curve by area under the curve of power spectral density is called average power. Okay, substitute that, then you simplify it further, then you will get E naught square by 2. This is the average power. In this problem we have discussed, okay, this is the question, just I will revise it. Okay, next what we have discussed, x of t they given, identify the power spectral density and average power. Power spectral density and average power. Okay, here they discuss the, okay, for power spectral density, here having the formula, you can use this formula. Okay, this is one of the approach. Second approach also you can follow, x of t, first you have to solve the autocorrelation function. Okay, now after completing, to solve the power spectral density of that. First, that is another method to solve the power spectral density. Next, after finishing that, calculate the average power. Average power, you substitute the power spectral density term, then you will get the final resultant of the answer, omega minus omega naught. Okay, you will get, this is a omega minus omega naught, del of omega minus omega naught, del of omega plus omega naught. We are having the E naught square by 2. Okay, then you are going to get the resultant is A naught square by 2. Okay, A naught square by 2. Okay, here you can observe that what is the formula. Second type of formula is, first you have to apply the autocorrelation function. For that, second method is what you have to do is, first you have to solve the autocorrelation function. For that, what is the expectation of x of t plus tau. Now what you are having, expectation of A naught cos omega naught t plus theta into A naught cos omega naught t plus tau plus theta. Okay, this one we already solved it. When you apply the autocorrelation, you will get the answer A naught square by 2 cos omega naught tau. This is the autocorrelation function. Now what we have to do after completing the autocorrelation function, next we have to apply the power spectral density. This is the formula. Okay, this is the formula we have to use. Now we know the value of autocorrelation function, which is integration minus infinity infinity a naught square by 2 cos omega naught tau e power minus j omega naught tau. You consider omega naught tau. Okay, you simplify it further. Now here this one you have to calculate in terms of e power exponential terms. Okay, in terms of exponential terms, that part we have solved here. E power j theta. Okay, if you are considering omega, okay, omega naught, then what you are having a square by 2, take it outside. Here integration minus infinity infinity. Here e power j omega tau minus e power minus j omega naught tau by 2 into e power minus j omega tau. Okay, now you have to simplify it further. Again, you will get the answer. This is the answer you are going to get. A square, a naught square by 2 sigma pi omega minus omega naught plus omega of omega plus omega naught. Now again we have to calculate average power by substituting average power is equal to, you have to use the area under the substitute the power spectral density, then you are going to get the average power, that is a naught by 2, a naught square by 2. Okay, two methods you can follow based on the two relations. We are having the first method, we have solved that. In the first method, what we have solved, first you have to take the x of first method, this is xt of omega, then conjugate, then apply the product, then multiply it, then next what you have done, limit, you have to use the formula limit tau t tends to infinity, expectation of mod of xt of omega whole square by 2t. Okay, when you apply it, then you will get the resultant answer. Then you finally solve the, then you can substitute it, then you are going to get average power. Two methods you are having. This is first method. Second method, you are having first x of t, you have to convert into autocorrelation function, then you have to substitute in power spectral density. After completing that, then again you have to use the same formula to calculate the average power. Thank you.